Welcome to the Dummy Programmer. So today we are going to solve the three-sum problem on Leetcode. It's a medium level problem, and it's slightly more complex than the two-sum problem that we did in the last video. Please make sure that you solve that first. But I'll walk you through this. I think you will understand. It uses the same two-pointer approach. Let's understand the problem first. So it says that given an integer array nums, return all the triplets where the sum of the triplets is equal to 0. Okay. And they have to be basically unique numbers. And it also says that the solution set must not contain duplicate triplets. Okay. So this increases the complexity a little bit because now you also have to watch out for not producing duplicate results, right, in each iteration. We'll see how to do that. So if you look at this array has a mix of negative and positive numbers, and it's not sorted in any manner. And then the expected output is something like this. It's a list of list, right? So let's see how to solve this. If you look at, if you think of it in a naive way, you could have 3 nested loops, right? So the first loop goes from, say, so I points to -1. So it goes from -1 to -4. The second loop points to the I plus 1, the next number after I. So let's say the second loop goes from 0 to -4. And then the third loop points to j plus 1. So it goes from 1 to -4. So in this way, in the nested loop, in the deepest loop, you can check for the current value of I and for the current value of j and the current value of z, do they sum up to 0? And also please note that it is asking for all possible triplets, right? It's not just asking for one triplet, or it's not asking whether a triplet exists or not. It's asking for all the triplets. So you have to come up with an efficient solution which gives you all the triplets in reasonable time. So this three loop approach is going to be very inefficient. It's going to be O n cube. So we have to do better. So how do we solve this? So let's see if we sort the array, so it will become -1, -1, 0, 1, and 2. Okay. So if you sort the array, this is what we did in the two-pointer in the two-sum problem. With the two-pointer approach, we sort the array. So let's understand the two-pointer approach for people who didn't watch that. So you have a sorted array, and then you have 2 pointers. One points to the lowest number in the array, and the second pointer points to the highest number in the array, right? And then we check the sum of the numbers at those 2 pointers, and we check if it is equal to the target sum or not. If it is less than the target sum, then we increment the left pointer because it's an ascending, the array is in ascending order. So we increment the left pointer. If the sum is less than if the sum is greater than the target value, we decrement the rightmost pointer, okay? Because that is going to bring down the sum. So that is basically how we solve two-sum problem using two-pointer approach. So here the complexity is that it's a three-sum problem, so we have to find 3 numbers which add up to a sum, right? So how do we do that? So let's say we walk through the array once. And at each iteration we fix the first number. So we say -4 is so we have one pointer per I which is pointing to -4 at the moment. So 0th index. So you have another pointer which is pointed to I plus 1. Sorry. And then you have another pointer pointing to the end of the array, right? I'm going to solve the whole thing, but I'm just explaining the problem and how we are going to solve it. So this is like array dot count minus 1. So this is pointing to the last element. So now for each iteration, so for I pointing to 0, we are going to walk j and z towards each other, towards the middle. And at each step, we are going to check if the sum of I, j, z is equal to the target, which is 0 in this case. If it is equal to the target, then we are going to add it to our list and we are going to increment I. Okay. And then we are going to increment I until we reach this point, because we are looking for a triplet. So there have to be, two numbers after I. So that's why we have to stop here. Okay. We're also going to check for duplicates. You'll see how we do that. But this is the whole thing that we're going to implement now. So let's see. So let's first declare our results array. And return the results array. Okay. Now we have to sort the input array to sort the so in Swift, if you know, arguments are immutable. So we have to take a mutable copy of that. So you do this, and then we sort the array. Okay. I think this is the syntax to sort. Now, what are we going to do? So like I said, we have to, so we have one loop going from the start element to the end element. So it is going to be while I is less than, so we have to stop at the third last element, right? Because we need two more elements after that, because we're looking for triplets. So we have to do numbers dot count minus 2. Okay, so it's less than, so it is one step before that. Okay, so now, and we have to obviously increment this 1. Okay. So so what happens if the first two elements, so two consecutive elements that I is pointing to are the same? We have to skip it, right? Because it's asking to skip duplicate triplets. It cannot be duplicates triplets. So what we do is, if I is greater than 0 and numbers I is equal to numbers I minus 1, in this case, we increment I to I by 1, and then we say continue, because we have to go to the next iteration. We have to skip this element. So basically, so I hope you understand that when it comes here, I has been freshly incremented. The previous I has already been processed, right? The element at the previous index has already been processed, and we have increment I by 1. But when we arrive at this new value of I, we find that it matches the same value as the previous one, and we don't want to repeat it. So that is why we increment I by 1 and we say continue. Okay. Now we need a left pointer. So left pointer would be I plus 1. And then you have right pointer, which is equal to numbers dot count minus 1. Okay. So now we have to do that standard loop. Left is less than right. We walk them through until they meet, right? So when we start this loop, we have to check for sum, right? So we have to see numbers dot I, and then you do numbers left, and you do numbers right. Okay, we get the sum. Now, if sum is equal to 0, that means this is the time where we need to add the triplet to our results array, right? So let's do that. Let's append. So you have, I'm just going to copy this, I don't want to type out everything. And then what's going on, huh? And then we have this, right? So we've added our result. Now, it's the same thing. So now we know that we need to update our left and right pointers to move to the next iteration, right? Because we know that this iteration works. Now what happens if you find a duplicate element for left or for right? We have to skip it, right? It's the same thing that we did here. This was executed after I was incremented in the previous loop, right? So here also, before we move to the next loop, we have to increment left and right. And here we have to check if the new number is the same as the previous number or not. So how we do that is this. So we do this. So this obviously has to be checked. And then we check numbers left is equal to numbers left plus 1. You can increment left and then check for, left equal to left minus 1, or you can do this. It's, up to you. So when you do this, so until, so you have to keep updating this pointer until you reach the last duplicate value. Okay. This will execute until we know the next value is going to be unique. Okay, at least different from the previous numbers. So that is what we are doing. And the same thing we have to do for the right pointer. So this is right, and right has to move towards the left because it's walking backwards. So it is right minus 1, and we do right, and we decrement, right? And now we know that the next number is going to be unique, right? We are currently pointing to a duplicate number, but we know the next number is going to be unique. So you do equal to left plus 1. And then you do right equal to right plus right minus 1. Okay. This is basically the core of the logic. If you understand this, then you understand the problem. Okay. Otherwise, it's the standard thing. If sum is less than 0, then we need to increment the left pointer because we have to increase the sum. Else, we have only one condition left, which is sum is greater than 0, then we need to decrement the right pointer. And then I think this is it. This is the solution. I think this should work, no? Let's run it. Unless I did some typo. It worked in one shot. Awesome. Okay, I think it worked really well. Runtime was really fast. One more thing, there is a small tweak here that you can do to even make the performance even better. And that is if you consider an array of only positive numbers, right? When you sort it, the first element is a positive number. Then you already know that the sum is never going to be 0. For the sum to be 0, it has to be a mix of negative and positive numbers, right? Or all numbers have to be 0, in which case, again, So to do that, we can add a small check here. I think it's a small detail which, if you mention to your interviewer, they'll probably like you. So it's up to you. It's a small detail. So if I is equal to 0 and numbers of I is greater than 0, then you break out of this loop, right? You don't have to do any of these things. So I think this was the solution. I hope you liked this video, and if you did, please like and subscribe. It was nice having you. Have a good day. Bye-bye.